Welcome back to Voltage Learning. Let's walk through a core hardware interview concept, this time focused on digital timing fundamentals, something NVIDIA and other ASIC teams care deeply about. The question asks, when checking a simple flip-flop path, what does a hold time requirement actually protect against? This is not a trick question, but it is a filter question. Interviewers use it to see whether you understand what's happening at the flip-flop right around the clock edge, not just whether you can run timing tools. Let's think about how a flip-flop works. When the clock edge arrives, the flip-flop captures the value on its data input, but it doesn't capture that value instantaneously. The data has to remain stable for a very short window after the clock edge so the internal storage node can settle correctly. That's exactly where hold time comes in. If the data changes too soon after the capturing clock edge, often because the data path is too fast, the flip-flop may latch the wrong value or enter a metastable state. Hold time is there to protect against that scenario. Now let's quickly eliminate the other choices. Issues like scan chain drive strength relate to test infrastructure, not functional timing. Reset releasing before supplies stabilize is a power-up and initialization concern, and a clock arriving too late relative to launch is a setup time issue, not a hold time issue. So the correct answer is data changing too soon after the capturing clock edge. This distinction matters a lot in real silicon. Setup problems are usually fixed by slowing clocks or optimizing logic, while hold problems often require adding delay, sometimes intentionally making a path slower. If you're preparing for ASIC design interviews and want explanations that reflect how engineers actually think on the job, this is exactly what Voltage Learning is built for.